You're listening to the Patenting for Inventors podcast with registered patent attorney, Dr. Adam Diamond, founder of Diamond Patent Law, the #1 source for securing your intellectual property needs. Now, here's your host, Adam Diamond.
Hello and welcome to the Patenting for Inventors podcast, episode 14, Patent Drawings. My name is Dr. Adam Diamond, founder and owner of Diamond Patent Law in Los Angeles, California, and I can be contacted through my website at patentingforinventors.com. That's patentingforinventors.com to answer all your patent and intellectual property questions. This podcast episode is related to patent drawings for a utility patent, not a design patent. I'll cover design patents and patent drawings and design patents in another episode. The first thing you should know about patent drawings is that you probably shouldn't do them yourself. You can't just draw something, even if you draw it really well, and usually have the patent office accept it because there are lots of rules about what's required and what's prohibited in the drawings. I like to do my drawings after I do the claims instead of trying to do the written description first, because once you have your drawings, I think it makes it much easier to write the rest of your application because it's mostly just going through in detail discussing every part in your drawings. This is going to be a pretty technical podcast episode because there are just lots of technical requirements, but if you go to Google and type in 37 CFR 1.84, you'll find a page that goes over all the rules. In this episode, I'm just going to go over some of the major requirements that you need to know. There are exceptions to some of these rules, but if you follow these rules, there will be a lower chance of getting an objection rather than relying on one of the exceptions. We can break down the requirements into 4 parts: rules of the page, rules for drawing the invention, rules for labeling, and rules for lines. For the page rules, your drawings have to be on 8.5 by 11 or A4 paper. For the margins, you have to have at least 2.5 centimeters on the top and left, and 1.5 centimeters on the right, and 1 centimeter on the bottom. To make it easy on myself so I don't have to remember all that, I just make all the margins 1 inch on every side. The patent office prefers that drawings are drawn in the upright vertical orientation of the paper, but if your invention is a lot wider than it's tall, then it's okay to rotate the page so it's horizontal. Those are the main rules for the page requirements. For the invention itself, you need to make as many drawings as are necessary to show all the parts of your invention. Most of the time, this requires you to do multiple views of the same embodiment. Sometimes you'll have to do a cross-section or other view if you need to show something on the inside of your invention. There are some standard views that you'll see in patents, and you don't necessarily need to put all of them in, but you should be aware of the standard ones, which are top, bottom, side, front, rear, perspective, and cross-sectional views. You can also have views that are called exploded views, which is a view of your invention when all the individual pieces are separated from each other. There are variations of these views, but these are the main ones. You can see some examples of patent drawings in the patent I've talked about before for the avocado slicer. Do a patent search using Google Patents for a U.S. patent number 8726799 and look at the drawings there because I'll refer to some of the things in there in the rest of this episode. In your drawing, the lines of the drawings should be black and clearly legible. Don't make them too thin, and don't draw lines that are too close together. The lines in your drawings should be clear and separate enough so that even if the drawings are shrunk down to 2/3 of the size, each line is still distinct. You also don't want to put anywhere in your drawings about not being drawn to size or saying what the proportions are. Using shading in your drawings is fine and even encouraged to show curved features of your invention, but generally don't use grayscale. Use curved lines to show shading, or you can use a technique called stippling, which is a bunch of little black dots that help show shading. You can also use different patterns to differentiate different parts of your invention, but don't use blocks of black or variations of grayscale if you can avoid it, because you'll often get an objection if you do that. In the avocado slicer patent, they didn't use any patterns, but you can see how they use lines to show the curved surface of the device in figure 2. The next thing is labeling. Several things are labeled in your drawings. The sheets are labeled, the figures are labeled, and the individual parts of your invention are labeled. Each sheet has to be labeled with 2 numbers. You won't see these on the printed patent, but you have to do it when you file your documents. The sheet numbering has to do with what sheet it is and how many sheets there are in total, and you need to put this in the top, middle, but not in the margins of the page. After the sheet number, you put a slash, and then after the slash, you put the total number of sheets. So if there are 5 sheets, the first sheet will have a 1/5 in Arabic numbers. The next sheet will say 2/5, etc., until you get to page 5/5. This is important because if you ever have to make any changes to the drawings, the patent office is going to want to know what sheet of drawings you're referring to. Next are the figure numbers. Next to each figure, and I usually put it below, the figure is labeled Fig and then a period. So the first figure will be Fig 1, then Fig 2, etc. You can put more than one figure on a page if it fits, but you don't have to. If you look at the avocado slicer patent example, look on the second page of drawings, which has figures 3 through 6. You can see that they fit 4 figures on a single page. As long as you can do it without making your figures too small, it's fine. Next are the reference numbers. You shouldn't put any words in your drawings. If there's really no way to show the invention without putting in a simple word like steam or open, or sometimes schematic drawings or flowcharts will have a few words, but try to avoid words if you can. Instead, almost every part of your invention is going to be labeled with what are called reference numbers. What you do is put in a number near the part, and then draw a line from that number pointing to the part. Most drawings will just use even numbers for all the parts, but there's no rule about that. I think it's useful to use even numbers or just to skip a number, because if I forget to label something between two numbers, then I could add the odd number thing between those two numbers, so the numbers in the figure are all numerically right around each other. What you do with the numbers in the application is that when you're writing the description of your invention, every time you mention that part, you also write the corresponding reference number in the drawings so that someone reading your application can follow along with the drawings. For example, if you look at figure 3 of the avocado slicer patent, look at number 302, that's pointing to one of the slicing blades. And if you look at the description of the invention, you'll see that every time the inventor says slicing element, it's followed by the number 302. It's almost always better to overlabel than to underlabel your figures. So even something that looks as simple as a 3-in-1 avocado slicer might have 50 or more different parts labeled. Another thing is, you want to keep your numbering consistent through the figures. So if you label the slicing blade 302 in figure 3, that same slicing blade, if it's also in figure 4, also gets labeled as 302. Don't give it a new number just because it's a new figure. As for the sizes of labeling everything, there are specific rules about sizes, but the way I do it is that I'll use size font 12 for the reference number, size 16 for sheet numbering, and size 36 for figure numbering, and I haven't gotten any objections based on that. The last part are the lines, and this actually goes along with the reference numbers. You shouldn't put the reference number on top of the part in your drawing. You should place it near the part, but not right next to it. You want to give some space between the part and the reference number, and then from the reference number you draw a line pointing to that part. This is called a lead line. Most people draw their lead lines with a little bit of a curve and not totally straight, but it's not a hard and fast rule. I just think it looks a little bit cleaner when the lead lines are slightly curved because you make out the differences more easily between the invention itself and the lead lines. You usually have the end of the lead line touch the part in your figure, and you don't put an arrow at the end of your lead line for most parts. You use arrows when you want to point to general regions or sections or specifically point to a surface of an object. For example, in the avocado slicer patent, if you look at figures 3 through 5, you'll see reference number 280 and an arrow at the end of that line pointing to a part of the device. And if you read the application, 280 is listed as a knife. In the drawings, you'll see that the line from 280 has an arrow that just points to the general knife region of the device and not actually touching the knife region. In that general knife region, you'll see other numbers like 292, which is listed as a first edge, or 294, which is a second edge. Both 292 and 294 are specific parts of the knife region, which is why they don't have arrows, but the general knife region does use an arrow because it's pointing to the whole region of the device. If you want to point out a particular surface, you also want to use an arrow. For example, maybe you want to specifically mention the inner surface of an object. Then the arrow should actually touch the surface of what you're pointing to. Also, another important thing about the lines is what I call the Ghostbusters rule of lead lines. If you remember from the movie, they use proton packs that shoot out proton streams, and Egon said, "Don't cross the streams. It would be bad. Try to imagine all life as you know it, stopping instantaneously, and every molecule in your body exploding at the speed of light." So think about your lead lines as the same as the proton pack streams. Do not cross them. Lead lines should never cross over another lead line. If you have to draw a curved line to go around another lead line, then do that, because if you cross lead lines, you're going to get a drawing objection. As I mentioned in the beginning, I'd suggest hiring someone to do your drawings. Even patent attorneys don't generally do the drawings themselves. They hire someone to do it for them. Drawings might be between $20 and $50 per figure, depending on the person and the complexity. So even if you need 10 drawings, which is on the high end, we're talking maybe $500. In the grand scheme of things to your business or invention, this is a pretty low cost because in the end, it will save you a lot of headaches and most likely you'll probably get an objection if you try to do it yourself. And then you'll have to pay someone to fix it up for you anyways, so you may as well get it done right to start with. If you want help with drafting your patent application and drawings, I do offer those services through my practice at Diamond Patent Law. Please check out my website where you can contact me at patentingforinventors.com. That's patentingforinventors.com. I'm Adam Diamond, and until next time, keep on inventing.
Thanks for listening to the Patenting for Inventors podcast with host Adam Diamond. If you enjoyed the show, please rate and review on iTunes. The contents of this podcast are intended for general informational purposes only. The facts of every legal matter are unique, and the content of this podcast should not be construed as offering legal advice for your specific legal situation. For more information and help with your own intellectual property needs, contact Adam Diamond at patentingforinventors.com. That's patentingforinventors.com. Or call Diamond Patent Law at 424-281-0162. The preceding information may be considered an attorney advertisement and does not establish any attorney-client relationship.